This short video will explore the analysis properties of materials. Materials are pretty pictures, literally. They also drive both drafting standards as well as physical properties. So let's take a look. Jump into your structural model of any model, really. I'd like to select my foundation wall. Click Edit Type. For the structure, let's click Edit. Let's find our materials here. Concrete, cast in place, gray. Click on your browser button. I'll expand my dialog just a little bit. Of course, we know about identity, we know about graphics and appearance, but when we jump over to physical, and we drill into, say, concrete, we know what our concrete compression is, 3.5 KSI. We can click on lightweight. This stuff matters, because when we send this stuff over to robot or any other structural application, it's going to read these materials if that application is able to do so. Thermal behavior, all of this stuff actually matters. So when you're modeling stuff in Revit and you're thinking about doing structural analysis using your Revit model, a lot of times this stuff needs to be filled out. Generally, it will be if it's a material you use that came with Revit, but if you create your own material, there's a chance you'll have to go through and change these properties. Click cancel here, click cancel here, click cancel one more time, hit escape a few times. And of course, we can always go to manage materials. Now we can find any material we want. So if we type in conc, most of these should have their physical material selected. You can come in and change these. So when it says concrete lightweight 4 KSI, we see right here that this is 4 KSI. 3, 4, 5. Recast. Let's hit cancel. You just skip a few times. There you go. It was pretty short, but now you're going to have to pay more attention to materials. Another short video that's going to explore where the analytical settings are stored and what to check for. Let's do it. Let's take a look at our analytical settings. Before we get started, what is an analytical model anyway? Let's say we have all of these analytical views. Now 3D views, we have 3D views and we have analytical model. Double click on analytical model. Here is our model based only on analytical lines. Go ahead and select any one of these lines. Maybe I'll select this column. We're analyzing it as gravity. Analytical links, if we check that on, it means it's going to link to members that are framed into it. By virtue of snapping to these, it's going to link them anyway. Let's scroll down till we find top alignment method. Again, auto detect is generally best, but if we click the drop down, we can go to projection. And on our diagonal braces, we're going to have to do that, and we'll look at that in a moment. So for all of these defaults, I like to keep them. For our base release, we can either go fixed, pin, to bending moment, or user define. So if we do user define, what's going to happen is our bases now, we're going to be able to control these. If it's going to be released around these axes, we check those on. If it's pinned about them, we leave it unchecked. If we scroll down to member forces, let's click edit here. This gives us our member forces. We have our end reactions, our compression and tension. Now we can specify what these are in terms of kips per feet. Because we're set up for English units, we're going to use these standards. Click cancel. Escape a couple times. Notice now that all of your walls and floor slabs have analytical surfaces. So if I select this, there's not a lot of properties, but there's a few. So we're going to analyze that as gravity and lateral. Of course, it's a wall. It's a foundation wall. Alignment method. We can either auto-detect or go projection. Again, if we're extending past corners, or if we want to deal with that separately, we can go to projection, and it will change how those ends form. This one won't change because when we modeled it, we were able to join those together physically in the model. That's the alignment method. Path extension method, same kind of thing. We're able to model these with constraints. We don't need to deal with that. We're just gonna auto detect it. Apply. Just skip a couple times. Go to the Analyze tab. Click on Analytical Model Tools and find a Settings icon and click it. Analytical Model Settings. Generally, these are turned off. If you want Revit to give you an error every time you draw a member or a beam, turn that on. If you don't want it to give you an error, just keep that turned off. Analytical Physical Model Consistency, I'm going to keep that turned on. For tolerances, I could keep these about where they're at. 6 inches for analytical to physical model distance is about far enough. What's going to happen is if we start decreasing or increasing these numbers, you'll get more errors. Sometimes errors are good, sometimes you know that. When you're in the middle of modeling something, you don't want all those errors. But we can go back and physically push our checks. So we can check for consistency. So when we do a consistency check, it's going to check for all of these. So what I want to do is click OK. You want Revit to perform an analytical model check at this time? Sure. Analytical physical model consistency check is complete. If we click on the Expand Warning dialog and drill into our warnings, I think I know what that warning is. So if I hit close here, let's go to our actual 3D view. Double click the 3D. Now if we come in here, we'll notice we've got ourselves a bit of a bust. Go ahead and select this analytical line. Where it says Start Alignment Method, it's auto-detecting, but it got kind of screwed up. Click the drop down, let's go to Projection. That's okay, hit OK. And the start of that is going to go to the projection now. Again, select this again. And Alignment Method, we're going to go to Projection. Click Apply. That's going to project that back to where that should be in the middle of it. Now we can do the location line, center, right, and even those at the grids that we're on. So that's pretty cool. I want to keep it at center. So let's do the same for this one. Start alignment, projection, click apply. That's fine because we know that we had that 6-inch tolerance set. Click OK, because that kicks it off like that. It doesn't like it. Now, end alignment method. We're going to go to projection, click apply. There we go. Now that's going to put it in the spot where we want it. So here we have it. Now our settings are literally set. With the out-of-the-box Revit structural template, we get 9 predefined load cases. They're pretty typical. It's our load cases that we assign when we place loads and boundary conditions. In this video, I'd like to make a new load case and assign a load nature to it. Open up the model you've been working in. Go to the Analyze tab. Under Analytical Models, we have Load Cases, we have Load Combinations. Go ahead and click Load Cases. It's going to jump into our structural settings. We just looked at this dialog before, but now we're looking at our load cases. Notice that we have name, case number, nature, category. Okay? You can change each of these. So what I want to do is quickly make a load nature, then we'll assign it to our load case. So on our load natures, click Add. For new nature, I'll just call it mechanical equipment. Now keep in mind, I'm just making these up. If you have an actual load nature that you want to create, you create that. Hit Tab. Now for our load cases, let's click Add. The new load case, we'll call it AHU. Case number 9. For the nature, drop down mechanical equipment. And for the category, we'll keep it at dead load. Click OK. Now, if we're to place a load, we're going to place one and delete it. We'll go with hosted area load. Make it right here. Notice that when we select our area load, our load case, it's set for dead load, but we can come down through. We can grab AHU if we want. Obviously, we're not going to have that big of an AHU unit, so we're not going to actually apply it to this area. That's for another chapter. Hit escape a few times, just select that load and hit delete. So there you go. Make as many load cases as you wish. Yeah, you guessed it. We can combine forces to dominate the universe. I'm kidding. We can't dominate the universe in Revit. That's a feature in next year's upgrade, though. In this video, we'll make a load combination. Then we'll create a formula and a load combination usage. Let's jump into the model we've been working in. Doesn't matter what view we're in. Go to the Analyze tab. Now let's go to Load Combinations. We can add a formula. We can use a load combination usage. Notice that these are all grayed out. We can't do anything because we need to have a load combination to begin with. So for load combination, click Add. For the name, again, we'll call it Mechanical Equipment. Perfect. Now notice that we can add a formula. So click on Add. Notice that when we do that, we can apply a load. And we can apply a factor of that load. So if we want a gravity load combined with a lateral load, we can do that. So let's click Add again. For that case or combination, we'll click the drop down. We'll go LL1. And we can change the factor. So if we want to double up on LL1, we'll just change it to factor of 2. But notice what's happening, it's putting it in our formula here. So we can design a dead load, or if it's a giant chunk of equipment, a lateral load. Right? So for the type, it's a combination. We're combining two different cases together. Notice that load combination usage, we can click Add here. We'll call it Mechanical. If we click on here, it's going to set it. Notice now that the state is serviceability. We'll keep that as serviceability. It's something that's going to be installed on top of a frame. For usage, Mechanical works for me. So we can add as many formulas as we want. Notice though, once we apply that formula to it, this is gone now. If we select this, we have more factors, we have more case or combination formulas. So we can keep adding as many as we want. Click OK. There you go. That's how you make a load combination in Revit. Now that we've combined forces that dominate the universe, we can start placing boundary conditions. By doing this, we can establish a point, a line, or an area where we want to apply to our analytical model. In this video, we're going to place point boundary conditions to the bottom of all of our piers and pilasters. Then we'll place the released boundary condition to the top of all of our steel columns. To get started, let's jump into Revit. Browse to where you're keeping your exercise files, and open the structural model. Of course, you can open any model you want. In the project browser, let's go to 3D views, and let's go to analytical model. Here we have our analytical model, but we don't have any loads placed. Let's do that. Go to the Analyze tab. Let's go to Boundary Conditions. And notice we have one of three ways we can do this. In this case, I want to add a point boundary condition. And I want to add a point boundary condition. If you notice, we're going to map to all of the bottoms of our piers and pilasters. So I'm going to go around and do that. It's going to take a little while, but we want to hit all of them. It's very easy to do in a wireframe view. And now I want to do the same thing to the bottom of our steel columns. Try not to miss any. These get a little bit harder to do in the middle. Get lost in a sea of lines. Look at it from underneath here. Get one more row to go. That's all of them. Okay. Now I want to do the same thing to the top of them, only the state. I want to change it from fixed to user. Now we can change where we want it to be able to move. So I guess we'll just choose rotation about. We'll say Z rotation. We're gonna go release. Z translation, we're gonna hit release. Now we're gonna click the tops of all of these and notice that we're gonna get a bit of a different icon. Go through, we can now ends of all of these use that frame into this. We're just gonna do this on the exterior. There we go. Let's do the same to our smaller columns here. Sometimes it's hard to grab them. I'll do the same to the tops of these. There we go. Now we've added all of our boundary conditions to our point loads dealing with our columns. Now that we're holding up our columns, we can go on to larger things. This short video will explore the analysis properties of materials. Materials are pretty pictures, literally. They also drive both drafting standards as well as physical properties. So let's take a look. Jump into your structural model and any model, really. I'd like to select my foundation wall. Click Edit Type. For the structure, let's click Edit. Let's find our materials here. Concrete, cast in place, gray. Click on your browser button. I'll expand my dialog just a little bit. Of course, we know about identity. We know about graphics and appearance. But when we jump over to physical, and we drill into, say, concrete, we know what our concrete compression is, 3.5 KSI. We can click on lightweight. This stuff matters, because when we send this stuff over to robot or any other structural application, it's going to read these materials if that application is able to do so. Thermal behavior, all of this stuff actually matters. So when you're modeling stuff in Revit, and you're thinking about doing structural analysis using your Revit model, a lot of times this stuff needs to be filled out. Generally it will be if it's a material you use that came with Revit, but if you create your own material, there's a chance you'll have to go through and change these properties. Click cancel here, click cancel here, click cancel one more time, hit escape a few times, and of course we can always go to manage materials. Now we can find any material we want. So if we type in conc, most of these should have their physical material selected. You can come in and change these. So when it says concrete lightweight 4 KSI, we see right here that this is 4 KSI. 3, 4, 5. Recast. Let's hit cancel. You just skip a few times. There you go. It was pretty short, but now you're going to have to pay more attention to materials. Another short. Let's place a load that is basically line-based. We do this by using a similar methodology as we do when we place basic components into our model. In this video, I'd like to place that AHU load we made into our model. Let's jump into Revit. In the project browser, let's scroll down where it says Penthouse. Let's open that up. Now, because we're in a model view, we're not going to be able to do what we want to do here. So I'm going to right-click on Penthouse, duplicate view. Let's just click on duplicate. Let's rename Penthouse Copy 1. Let's go Penthouse Analytical. And hit Enter. Right-click on Penthouse Analytical. Let's apply template properties. Select Structural, Analytical, Isolated. Click OK. Here we go. Now, zoom in on this area here. Go to the Analyze tab. Let's click on Loads. There's a few different things we can do. We can do point loads, line loads, area loads. We've done those. What I'd like to do is I'd like to just do a line load. Now, that line load, the problem is it's oriented to project, so I don't know where it winds up. So if you click into Project, click the drop down, and let's just go to Work Plane. That means that we're going to put it on the penthouse level. Now we can basically draw any shape we want. Click the chain button, it makes it easier. Point here, over to here, onto here, over to here, up to here. Now if you hold down your control key and select all of these, our load case, we can change that. We can hit the drop down here, put that on AHU9. Go to a 3D view. So now we have a non-symmetrical line load. It kind of serves as an area load in a way, but we can have different load cases or different loading on each of these lines. But we know now that we're hosted right to that work plane that we want it to be hosted to. Okay, we've done enough loading for now. That way we can go check out Robot. Although we can place and configure loads and load cases in Revit, we cannot do actual analysis in Revit. That's where Robot comes in handy. We now have a direct link to an analysis program that actually works seamlessly back and forth. So let's do it. Let's send this model over to Robot. Okay, jump into Revit, open the structural model we've been working on, or open any model that you wish to send to Robot. On the Analyze tab, notice that we have Robot Structural Analysis. If you don't have Robot Structural Analysis, the Results Manager, and the Results Explorer, please watch the Getting Started video at the beginning of this course. We have the downloads you need to have these items. Now, click on Robot Structural Analysis. Let's go to Robot Structural Analysis link. It's a two-way street. We can send the model, we can update our model, we can update model on the results. We'll update the model afterwards, but right now we want to send the model. Type of integration is going to be a direct integration. We could create an actual file that someone else could open. So for example, if we had someone else doing an analysis somewhere else, we just send this to a file, then they would open that file in Robot Structural Analysis. We do have send options, so click on Send Options. Specify the case that contains self-weight. Well, DL1 does, but that doesn't really matter. You can just use whatever the default top one is. DL1 actually works perfectly. I don't like to use plan views backgrounds. I don't like a lot of this stuff. Doesn't really work that well for me. Click OK. Okay, let's do it. Click OK. That's going to export it. This is not a huge model, so it's not going to take all that long. Now, what you won't see on my screen is the fact that it is actually opening Robot Structural Analysis, and we'll jump into that in a second. Sending to Robot Structural Analysis completed. If you want to view the events report, sure, click yes. Went through, no whammies, no whammies, no whammies. Excellent. So it sent it. I'm going to close out of my warning list. Now once I close out, Revit Structural Analysis Professional opens, and there we go. It's got our building, it's got our levels, it's got our loads. Now that we have it into Revit Structural Analysis, we'll start to go through and see how we can really look at our model and turn stuff on. Because it looks like there's some stuff missing. It's really not. It's almost like Revit. So, now that we're on Robot, we will see that there are about 100 icons and probably 1,000 ones that are hidden. That being said, let's jump into the robot and check out the interface. So in Robot, we're on that model that we exported. The first thing I notice is our loads aren't showing up. Our boundary conditions are there, but our loads are not. So what I'd like to do is go to the View tab, go to Display. Here's all the stuff we have turned on or off. Notice our load symbols aren't turned on, so I'm going to click on our load symbols. Click Apply, and click OK. If I hold down my Control key and my wheel button, it's very similar to Revit, so I can pan around. Now what we'll see over to the left is almost like the way Revit is set up. We have our Object Inspector, which is basically our project browser. So we have our stories, meaning our levels, and we have objects of a model. So if we drill on the beams, beam 52, they kind of renumber them, but that's okay. We'll get into that once we start making load combinations. And if I scroll into my model, I can literally physically select items. So if I come over here and select, say, this slab, what we'll see is we have that element and we have our properties. We can change these properties. When we change these properties will go back into Revit once we send this model back. You can hit escape a few times to deselect it, just like you can do in Revit. Now looking down here, we'll see what basically is the view control toolbar in Revit. So for example, if I want to see the section shapes, I can click on this icon right here, and we can see those section shapes. There they are. If we come down here, we can see our view settings. So if we click on, for example, structure presentation, takes a second. Now it puts grass down there. I don't think we want to barefoot it on grass, so that's kind of a funny presentation. Also, it's very slow. So close out of here. We don't really want to see that. And really, to be honest, having this stuff showing up is kind of off-putting. So now that we have geometry, we can jump over to groups. We don't have any groups yet, but we're going to make some soon. So remember, in geometry, if we go into penthouse, we can drill in. We can see all the beams that are in our penthouse. This also comes in handy too once we start trying to group stuff and do analysis right here in Robot Structural Analysis Professional. Kind of like Revit, huh? If I'm being honest, we could have actually modeled this entire thing right here in the robot. That would have been really silly since we don't have it, so we're not going to do that. That being said, now that we have physical objects in Robot, we can make any physical edits to the model we want. Of course, this is all fully transferable back to Revit. Let's do it. So in Robot and our model, I want to figure out what the slab is doing. So if we zoom into here, it's not easy to select. If you're having trouble seeing it, let's uncheck section shapes. It makes it a little easier to just see our analytical surfaces. Now, if you hover over just like about here, you're going to select that entire slab. They call it a panel. But if we scroll down here, we'll see the calculation. It's calculating it as a shell. We can do one or two things. The shell's made basically saying that it's a two-way slab, so I want it to be a deck slab one way. There's no real apply button, but notice that we have panels and we have stories here. So if we go back to panels, we'll see that we can select anything we want. So instead of a floor, we can make that a wall or a panel. Trapezoid, so we can change all of our analysis based on the physical model right here. But again, what I like the most about this is when we change something, we go back to Revit with it. So that way, when we're going back and forth between Revit and Robot, we're not duplicating our efforts. That was a quick video, but that's really how you do it. Next thing we'll do is we'll do some analysis and have Robot actually size our members for us. Since Robot is a finite analysis application, it makes sense that we can make load combinations right here. We didn't need to do any placement of loads over on Revit, actually. Let's automatically create some load combinations. So in Robot or in ML, go to the Loads tab. Now go to Automatic Combinations. Let's base our load combinations off ASCE 710. Let's select Full Automatic Combinations. Notice that we can click More. Regulations haven't changed, that's fine, hit Yes. Now we can accept all of these as defaults. Notice that we have our load cases, they're all turned on. Combinations, we're going to make all of these combinations right here. We can add groups, relations, but in this case, we're going to go with combinations. We're just going to click on Generate. Seems pretty simple, but we just automatically generated all of our load combinations. Like I said, we didn't really have to do any of these loads in Revit. In order to analyze surfaces, we need to create a basic grid, basically a mesh. This will allow us to actually see where our surfaces are supported, or sagging, or actually deficient. This is needed to proceed with other analysis. So let's jump in and create a mesh. In Robot, come to this little icon right here, Options of FE Mesh Generation. Click that. Now let's go ahead and click on Meshing Options. You haven't selected anything, so we're saying yes, mesh every panel in our entire model. So click yes. Now in our meshing options, let's go with complex mesh generation. We'll go with element size. It's 3.28 feet. I'm not sure where they get that from. I'm just gonna go with 2 feet. Hit tab. We can go to our advanced options. We don't really need to get into all of this, so let's just click OK. Now it's going to select all of our surfaces. Now what we need to do is go to Generation of Calculation Model. So basically with these selected, we're going to click this. It's going to start to run some analyses. A couple warnings: linear load has not been applied to a panel. It's okay, the element is not assigned to any story. These are okay, we have the warnings turned on. Let's click Close right here. Now if we zoom into our model, we can start to see the grid where it's starting to show us exactly where that mesh is. Obviously, it's an over-exaggeration of how this is going to perform, but if we look at it, we can see where we have deflection. We can close out of this toolbar. Hit escape once or twice. It'll deselect those items. Now we can see our surfaces. Now we have a mesh back onto the stuff. Pretty cool, right? Did I mention this can all be integrated back into Revit? So let's perform a simple sample analysis. In this video, I'd like to perform a basic analysis on all the BL1 cases we have in our model. Although this is a sample, this is how you can analyze all of your load cases. So let's jump into our model we've been working in, or whatever model you're currently working in. On the toolbar, let's find Analysis. Let's come down to Analysis Types. Here we have all of the analysis types that are in our model. We can always change the analysis type. If we click here, we can change whatever case we want. I want to keep the case we have alphabetically. It's helping me out here. Click Cancel. We can create a new one. I like the one we have. Of course, we can create any case here that we want. We can change the types. We have a case list, so if we click on this Browse button, here's all of our case lists, so we can add whatever one we want. Just so happens that alphabetically, DL1 is the one I want. And also, if we use a DAM, a direct analysis method, we could do that too. But I don't want to do that. I just want to use our model generation. So now click on Calculations. Get an instability of type 1 detected at node 24. So that's fine. We can hit Escape to ignore all warnings. We can get the warnings later. 6 warnings. Now we can read our nodes. We know what those nodes are. They all seem pretty consistent to be in the same spot. So let's click Close. Let's click Close here. It doesn't look like it did much when we did that. There's really no verification that we did anything, other than if you look down here at the very bottom, you see a little green light. Results available. So What I want to do now is let's go to the Results tab. Let's go to Maps. Well, now we threw a bunch of errors. Let's see what happens if we go to Displacements, UW. Click Apply. Click Close. Hey, now we can see where we're starting to get sides. If you look at the chart, purple's bad. Get up to white, which is fine. Notice that, of course, the white is at all of our columns. So there you go. That's how you view the results of an analysis. Okay, let's change some beam sizes. In this video, I'd like to group all the beams in the penthouse and perform a weight analysis. Then we'll be able to choose which framing members we want. So let's jump into Robot. Now, some of these settings are getting a little annoying. So the first thing I do is go to Results. Let's go to Maps. Now under Displacements, let's turn that back off. It's pretty cool, but I don't want to see it right now. Click Apply. You close out of the Maps dialog. Now what you'll notice is this item right here. This is our Layouts tab. This is very similar to how AutoCAD used to do it back in the good old days, where if we change to some predefined layout, it will give us some icons to deal with what we're doing. In this case, I want to deal with steel. So click the drop down. Let's go to Steel Design. Let's grab Steel Aluminum Design. Okay. Down here on the View toolbar, let's uncheck Calculation Mode so we can turn off some of the other mappings we had turned on so we can see our steel better. So what I want to do is up here, if I hover over my beams, they're kind of hard to see because I need to see what numbers these are. So if I come down to my little control bar here and turn on Section Shapes, I'm going to hover over one of my beams here and I see it says 270, 69, 68, 67, 66. So now I can see these. I know that I've got 270 through 266. That's kind of important to know. So over here on my Definitions tab, let's go to Groups. I want to add a new group. So for number, let's click New. Number 1. Now my member list, this is going to be 270 T. Oh, it's kind of funny how you have to do it. 266. Hit save. So now with our number here, we're going to come down to calculations. I want to do a code group design. Now we can list what we have. So let's click on list. Look, we have a code group 1. So if you click on 1, click add. Now click close. Now with this group, I'd like to optimize it. So we're going to click optimization. And we're going to go to options. And we can optimize it by weight. We click OK. Now once we're done with that, all we need to do is come down here and select Calculations. Now notice it doesn't like the W12 by 19, which I wouldn't think it would. So if you click on one of these, it's going to show you what it is. It's going to show you the results. Close out of that one. It's got a W6 by 20. We can look at all this, the results. It gives us the formulas it uses. Close out of there. Or W8 by 21, which is the favorable one. So this is the one it doesn't want, the one you could use, best case scenario. So I'm going to grab this W8 by 21. I'm just going to click on Change All. Now the perform operation will cause the changes in the database containing structured data may cause a change, of course. So click Yes. And you could almost see it kind of in the background. It changed those shapes. So click Close here. We can save these results so you can go back and look at it, but in this case, nah, we don't want to. So let's cancel out of that. Close out of here. There we go. Now let's go see how Revit gets updated. It's time to go home. In this video, I'd like to jump into Revit and bring our changes in from Robot. The first thing we need to do though, it's weird, but let's go ahead and perform another calculation. I'm just going to click this icon here. It's going to perform a calculation. It's going to throw the same errors as it did before. That's okay. So we can just hit escape to ignore these warnings. We'll get a calculation message. We can just close out of that. Beautiful. Now let's jump into Revit. On the 3D views, let's go to Analytical Model. Of course, I have opened up my structural.rvt model. I never closed it. On the Analyze tab, go to Robot Structural Analysis and click on Robot Structural Analysis link. Now let's click on Update Model and Results. The type of integration wants to be a direct integration. Click OK. Now we're going to get set results to Revit. So we can just call the model name Model 1. We can keep the defaults. Click OK. And there we go. It took a while. There's been some warnings. You want to read the warning report? Now that's okay. What I do want to see though is let's go to an actual 3D view. So double click on 3D under 3D views. Now if we zoom into our penthouse, notice that our beams have changed. Now we're good to go. There you go. It's good to be hollow. So now that our model is back into Revit, check it out. Let's go up to Results Manager. Go ahead and select Results Manager. Now, again, if you don't have Robot Structural Analysis, Results Manager, and Results Explorer, you need to watch the Getting Started video that I posted at the beginning of this course. Click Results Manager. Notice that Model 1, that's what we had before, and here it is. If you click Explore, it's going to check all our stuff. Now what we can do is we can take a look. So if we look at deformation, click Apply, we can start to look at our model analytically. There's a lot of work to do. If you remember those blue dips that we had in our model before, notice that they're here now. So now we can bring our model into Revit and check the stuff out. We can close out of this dialog here. We can turn on other things, results for surfaces, apply. Then we'll see that it's kind of dipping upward, dipping down. So there you go. That's how you use the Results Manager and your Results Explorer. This video is going to be quick. It's simply showing you how to do a save as. Notice that you have a save icon. You have File. So go to File. Go to Save As. Here it is. It's a robot file. Now there's a couple different formats we could save it as. But in this case, I want to save it as a robot.rtd file. I already have a file there. I'm just going to overwrite it. Go ahead and click Save. You want to replace it? Yes. Now, if you're ever in Revit and you don't have that file open, you can simply go to Structural Analysis link. We can click Update Model, and we can update from the intermediate file .smx. Click on Update Options. Again, none of these are applicable here. So I can hit Cancel. I don't need to do it because I've already updated it. Hit Cancel. And that's it. That's how you save an SMX file in Robot.